Welcome back, ladies and gentlemen, boys and girls. Hope you all enjoyed the food. In fact, we have activities even more appetizing for the day. Up next, we have the most awaited panel discussion on the skill sets essential for young scientists. In fact, being young aspirants ourselves in the field of space science and technology, the topic is of great significance, and we are blessed with an expert panel of greater experience in the topic of discussion.
In this rush of time, I am trying to shortcut the intro of our panelists. First, we have the key person in the panel discussion, that is Dr. K. Raji, Scientist G, Head of MPPL and APE, SPL, BSSC. And also, we have Mr. C.V. Karka. He is from ISRO as Outstanding Scientist in November 2007. And prior to his retirement, he was holding the position of Deputy Director, VSSC, in charge of Propellants, Propulsion and Space Ordnance Entity. Also, we have C.R. Thomas, who is the retired Deputy Director of Vikram Sarabhai Space Center of ISRO. And we also have Dr. Suresh Babu and Dr. Smita V. Kambi from SPL team. Both of them are young scientists and renowned in their respective fields of research. Dr. Suresh is a winner of the Shanti Swarup Bhatnagar Award and Swarna JNB Fellowship. He is also a fellow of Indian Academy of Science, Bangalore. Dr. Smita is a renowned ionosphere and planetary scientist and co-principal investigator of Chase 2 payload on board Chandrayaan-2. And I welcome Shiju Abraham also to the panel. She is from IASC. She is an alumni of IASC Bangalore. And I welcome all the panelists to this important discussion, the first session of UL Space Camp 2022. Welcome, and I am handovering the mic and position to the key person here, as you saw.
Yeah, thank you very much. I would like to introduce Dr. Shiju Chandran, who is the Group Director in VSSC, and he is one of the most important luminaries in the area of rocketry. He can talk about any area of rocketry, and he is such an outstanding person. Myself, Rajiv. What is the way you want to go ahead? You want to ask questions or you want us to tell something? I don't know what to tell you because it depends on what you want. So you can ask questions better, right? Do you have any? Or should we start? Very good. Yeah. First, you introduce yourself, your name.
Sir, my name is Rajesh. I am a 10th grade student from Government Girls Higher Secondary School, Chandala, Alappuzha. Sir, my question is, what is the importance of leadership for a scientist? The importance of leadership in their career.
Yeah. Outstanding question. Sir, Karta sir is the ideal person to answer that.
I would say, if you consider Dr. APJ Abdul Kalam as a leader, I would like to start with him. I was fortunate to join my service directly under him when he was the head of a division and I joined to work with him. I see the leadership in him in two qualities. The first thing, I'm just telling some incidences from that you can catch up what is leadership. He told me that I will be working on explosives. But in academic curriculum, explosives are not taught. It's coming from Baba Chemical Center, there is no explosive. So I told him that, sir, my fear earlier was the radiation effect. And I ran from BARC to ISRO, thinking that I am out of danger. But you are asking me to work on explosives. The radiation would have killed me slowly after I get cancer. But explosives, all on a sudden, I will no more. You know what he said? Karka, challenges. You have to take challenge. And you work. Sir, I don't have any experience. That is why I am saying you work. When you work, you will have problems, but you will learn. So he motivated a lot. Even when we had initially some failures, I talked about 1969, when ISRO never knew anything about rocket. So each failure when it happens, see this. Doesn't matter. Try it. It will work. Do you know why it failed? Modify it. That is one aspect of the leader. Because he always says that you can do it, you will do it, you will be successful. The second point what he told is, he never liked to be called sir. He never wanted us to say good morning to him. He never likes it. If you happen to say good morning sir, and say, yesterday what happened to that work what you wrote? He will immediately change to work. So he is a person who does not want to boast himself, being considered as a sir. He rather would like to know about the work and be with you. That is second aspect of leadership. The third point which I have seen is, if you do something good and if it is successful, he always project that person. He is the man, only the man who has done it. So look at him, you ask him how he has done it. So you get happiness to explain that how you have done it. So he motivates. And one who motivates is a leader. I think I have covered at least one part of what is leadership.
Yeah. Can we go to the next? Okay.
Sir, my name is Agni Vishili. I am from Kainati, GVHS Malapalli. Sir, my question is, what is singularity and is there any proof that it even exists?
Yeah. Good question. Actually, there are events in the universe or situations in the universe where the scenarios goes to singularity. Singularity, it may exist, it may not exist. It's a theoretical hypothesis. But the fact is, singularity exists. Singularity exists. Any further you want to add?
I'll just add to what you have mentioned. Singularity is a case where the known equations break down. Okay, so you have certain equations which define a physical phenomenon, and at a point, what we call singularity, the known equations will give a completely infeasible answer. The best example is, in a singularity point, an equation's denominator may become zero, right? So the solution becomes infinite, right? The classic example is a very simple example. Let me just tell you. There is an aircraft, okay, and then when the aircraft is flying through the atmosphere, what will happen? The air is rushing against the aircraft, right? Or rather, the aircraft is rushing against the air. Very simple problem. Now, imagine you have one air particle. It just hits the end of the wing, right? So at that point, the air particle has got two options. One is to go above the wing or go below the wing, right? At that point, it's a singularity point, right? So at that point, you have equations before the air particle comes and hits, you have equations after it goes to the proper bottom, but at that point, the general equations what we use to explain that phenomena will not give you the correct answer. So this is a singularity point in a very, very conventional physical sense. But some of the most complex and most well-known singularity points are in, as I was pointed out, in advanced astrophysics. Right? Black hole, is known to be a singularity point because some of the equations in that particular point, whatever we have used to explain a physical phenomena, breaks down. But a singularity point can be relative also. Today an equation may not exist, but tomorrow someone can come up with a better equation to explain that. Okay, the reason for all these gaps in these equations are, as you very well aware, a single equation doesn't cover the entire gamut of physics. For microparticles, you have quantum mechanics. For normal range of speed and mass, you have Newtonian mechanics. For extremely higher end, you have Einsteinian theories. But there are certain gaps into our understanding. So, in a single word, if you want to answer what is singularity, it is the gaps in the existing knowledge of our present understanding of science and the world. That's a simple thing. In that way, the singularity exists.
Can I ask something related?
Yeah, sure.
According to
according to Hawking's theory, mathematically singularity exists. Hawking proved that either universe origin from a singularity or it ends in a singularity, or both origin and ends in a singularity.
True.
So if singularity is something which represents a gap in the knowledge, so how we say that it origins from a singularity, the universe origins from the singularity, because that mathematical theory says so.
That's exactly what sir is telling. See, singularity is a mathematical problem. Singularity is also a problem associated with cosmology. The origin of the universe. It is a singularity. The ending of the universe. It's a singularity. It can be treated as a mathematically, a point where your equations break down. It can also be taken as the place from which the things evolve. Do we know what happened right at the time of the Big Bang? What was before that?
Before that, nothing, because the time starts.
We don't know,
from
nothing. There is nothing called nothing. So, that is the singularity problem. We are not able to tell what happened before that. And what will happen at the end? Everything now compresses together, goes into energy form. See, nothing can be coming out from nothing. There is still something. Correct? But only thing is the way we treat it. That's what sir told. Two things. One is a mathematical problem. When it comes to, like for example, denominator becomes 0. It's a singularity problem. The second is the evolution in cosmology. It can also be treated as singularity problem. So singularity exists and singularity is a hypothesis. Singularity exists in mathematics. Singularity is a hypothesis. For example, nobody knows whether Big Bang, is there any solid concrete proof that Big Bang was there? It's a hypothesis. Of course, it is most accepted hypothesis. Doesn't mean that we know everything about the Big Bang.
Sir, my name is Kirtna Jaydev and I am studying 9th grade in Ahmedabad Public School. So my question is, what is the difference between black hole and white hole?
Black hole and?
White hole, sir.
White hole. You want to have an explanation? Do you want? The thing is, none of us are true astrophysicists. So it will be very difficult to say about the white holes. What is that? The other terms are there are several variety of things like that. Unfortunately, I don't think we will be able to give you an authentic answer. We can tell about so many other things, but then it will not be converted into an answer.
What exactly is a black hole? It absorbs everything, including technically photons, because
That is.
so that's a black hole. So white hole is supposed to be just the opposite to that. Okay, now how exactly this works? There are a lot of theories, there are a lot of conjectures. That's why Dr. Rajiv said, we cannot say that this is the right way of explaining, but we can check up. It is something like positron and electrons. So you have in nature there is always symmetry. It has come out of a theory. For example, in nature there is symmetry always. So if there is a black hole, there has to be a white hole. If there is something just because of this gravity related singularity absorbs practically everything, there will be something which gives out everything. Right. So that is the concept behind that. So in a single term, this is the answer. That one absorbs everything, the other liberates it. Yeah.
Now I am asking a question about the skill sets. Now we know that there is a distinction between the theoretical fields and experimental field. So if we want to choose one field, how we determine which one is suited for us?
Very good. Suresh?
It's basically from theoretical and experimental field. Earlier there was a clear distinction in the earlier days, but now it is important to have both experience to do something, advanced science in this type. But theoretical fields always need very good mathematical skill. Mathematical skill, I mean, we need to, because probably because of the way in which we have to score marks, we normally go by proving theorems and all. But we should be able to use mathematics as a tool. But probably in our present day curriculum, it is not taught in that way, because that is why, because when we talk about, most of you are from the school background, but even addition, multiplication and all, we are using in our day-to-day. But when it comes to integration, differentiation, which we use in calculus, we normally use it to prove certain things. Basically, left hand side equals right hand side, and there is the mathematics. But mathematics is much beyond that. So when we start utilizing maths as a tool, and those who can do that, they will only become very good theoretical. So we can use this as a tool to predict. That is one example. But experimental skill, it is actually, you have to have a lot of practical skills. That comes from, many people, it is inborn talent. We know many people around us who may not be very good in academics, but they are able to do things in a much better way. So that is an inborn talent, basically. So that we will be able to identify in the course of our, in our academic thing, whether it fits into theoretical area or anything. But to become a theoretician, it is essential, it is important to have very good mathematical skill, and we should be able to. The way I told is that we all get full marks in mathematics. But that will not make us a very good theoretical person, because unless we are able to utilize mathematics as a tool. So that comes out of training and then an intuition.
I want to add, I can resist saying one of your points. I will tell you two simple examples. One is that of the great Albert Einstein. The second one is that of Michael Faraday. And Einstein famously once said, imagination is more important than knowledge. You might have heard this, imagination is more important. Why he said so? Why imagination is more important than knowledge?
Imagination has a creativity. Creativity.
Yeah, why you say that imagination is important than knowledge? Knowledge is something which is very concrete. The knowledge about coming here is an information which is a specific information. But imagination has no limit. So if you want to be a real scientist who want to perceive something completely new, you should have imagination first. The moment you have knowledge in the brains of improper scientists, it can be constrained. We all are constrained by our knowledges. That's why some people will say, don't do that. From their experience, which they themselves are converted knowledge, they are restricting. Right? So in science, that's not good. So imagination will give you an avenue, then you will postulate, then the mathematician will give you a very, very concrete formation. I will give another example is that Michael Faraday, who was invented, found out the fundamentals of electrics, modern electrodynamics, everything he has only started. But he was a very poor mathematician, he was not a mathematician at all. So he got the help of James Clerk Maxwell to form all the things. In fact, what we call as Faraday's laws are basically formulated by Maxwell. Even the great Einstein, who was a brilliant physicist but not so a great mathematician to match his physical skill, he had to get the help of people like Marcel Grossman to formulate the theories of relativity into mathematical form. So it's very, very rare that the person will have the mathematical skill as well as the physical skill to get a complete theory. But it requires two different types of approaches. An analytical skill practically requires imagination, and a mathematician gives a form. Unless things are formed into mathematics and proven, it will never be accepted as a theory. It will only be a concept, it will be only a postulate, it will be only a vague conjecture proposition. The moment it is converted into an equation which matches with the previous knowledge in terms of mathematics, then only it will become an accepted theory. So both are important. It all depends on the kind of person you are. If you are more into imagination, more capable of doing thought experiments, that is one level of skill. Suppose you are a very good mathematician, but both have to come and work together at one point of time to give productive research. Otherwise, they will go in independent lives.
Actually, we have an outstanding experimentalist here. Sir.
Okay, I think I would also like to add some other dimension. At least the initial questions are all astrophysics and that's all. But we are basically talking about scientists. Okay. So when we talk of scientists, you can become a researcher either in basic research or in applied research. Okay. Now this has a lot of difference. Basic research and applied research. Now, invariably, if you ask people from ISRO, bulk of us are applied research and a smaller percentage is into basic research. So that is something which when we say applied research, probably we work something, we design something and ultimately a product comes out. Okay, so that aspect also needs to be thought about when you think of the skills. And you need to be absolutely inquisitive. You need to always ask how and why. If you don't do that, you never learn anything or you're never able to do things. So when you come to this applied research format, you should be also good at model making. When I say model making, today people do mathematical models, but people also make physical models, working models, and all these things. So you need to do that, experiment out things, so the sense of experimentation. Okay, these are a few of the indicative things which you need, traits which you need to become a scientist. Okay, thank you.
I think now we'll come back to you. Any other questions? Yeah. Actually, English is not Malayalam. There's no problem. All of us understand Malayalam very well.
നമസ്കാരം സർ, ഞാൻ അഭിലാഷ്, ആലപ്പുഴ ജില്ലയിലെ GHS സ്ഥാപന സ്കൂളിലെ 9ാം ക്ലാസ് വിദ്യാർത്ഥിയാണ്. അതുപോലെ തന്നെ ആലപ്പുഴ ജില്ലയിലെ ഗിഫ്റ്റഡ് ചിൽഡ്രൻ പ്രോഗ്രാമിലെ ഒരു മെമ്പർ കൂടിയാണ്. സർ, എന്റെ ചോദ്യം, ഇന്നത്തെ ശാസ്ത്രലോകം തിരിച്ചറിഞ്ഞൊരു കാര്യമാണ് ടാക്യോൺസ് റേസ് ലൈറ്റിനേക്കാൾ ഫാസ്റ്റ് ആണ്. പക്ഷെ അത് പ്രാക്ടിക്കലായിട്ട് കണ്ടുപിടിക്കാൻ ഇതുവരെ സാധിച്ചിട്ടില്ല. അതിന്റെ ഒരു പരിമിതി, നിങ്ങളുടെ അഭിപ്രായം ഒന്ന് രേഖപ്പെടുത്താമോ?
Actually, firstly, documents എന്ന് പറയുമ്പോഴത്തേക്ക് നമ്മുടെ ലൈറ്റ് സ്പീഡിനെക്കാളും ഫാസ്റ്റായിട്ട് പോകുന്നതാണ് documents. It's a very good hypothesis proposed by ECG Sudarshan, Malayali. The problem is he couldn't provide experimental evidence for that. Not only he, nobody else could provide an experimental foundation for that. In that case, he would have got Nobel Prize. So, partly the answer, the question answer എന്ന് പറയുന്നത് അതിൽ ചോദ്യത്തിൽ തന്നെയുണ്ട്. എക്സ്പെരിമെന്റൽ എവിഡൻസ് ഉണ്ടാക്കാൻ ഇതുവരെ പറ്റിയിട്ടില്ല. So, ഒരു body means particle, not body, particle, traveling with a velocity more than that of light. There is no theory. Not the theory exists, but there is no experimental evidence for that. Any kind of experiment, this is a very good thing. Sara Nerthe was Hadron Collider. So there are so many efforts that are going into the fundamental particle research. Hadron Collider is a fundamental particle research വേണ്ടിയിട്ടുള്ളതാണ്. Tachyons, if it is detected, it will go in that category. One of the fundamental particles. But ഇതുവരെ detect ചെയ്യാൻ പറ്റിയിട്ടില്ല.
Okay, thank you, sir.
But it doesn't mean that it doesn't exist. നേരത്തെ ഒരു വേർഡ് വെച്ചു പോസിട്രോൺ ഇലക്ട്രോൺ പെയർ, ഈ ബ്ലാക്ക് ഹോൾ വൈറ്റ് ഹോൾ ഇത് വന്നപ്പോഴത്തേക്ക് ഇലക്ട്രോൺസിനെ ഡിറ്റക്ട് ചെയ്യും. പക്ഷെ അന്ന് തന്നെ പ്രപ്പോസ് ചെയ്തിരുന്നു ദർ ഇസ് പോസിട്രോൺ. പക്ഷെ പോസിട്രോൺ ആരും കണ്ടുപിടിച്ചില്ല. കുറെ വർഷങ്ങൾക്ക് ശേഷമാണ് അത് കണ്ടുപിടിച്ചത്. തിയററ്റിക്കലി positrons existed that time, but nobody believed because of lack of experimental evidence. Subsequently, it was detected. Now we know that there is positron, isn't it? Same way, tachyons, somebody may come out in future. In which case, there is one more thing which will happen. Theory of relativity will be the foundation for theory of relativity. Maximum speed is light speed, so there will be problem. Yeah. One of it, you can choose.
Hi sir, my name is Neeta Halakuru. I'm a class 10 student of Commonwealth High Secondary School, Cherpala, Alapura. My question is about space debris. What would be the harsh impact of space debris which could be happening in future? And is it something which could be a threat to mankind?
It will be a lovely question to several of us. You start.
Actually, space debris, as the term denotes, it's more a threat to space-related entities than Earth. So that we have to be clearly distinguished. Space debris, as you are aware, what exactly is a space debris? Whatever which we have launched to space, which is no longer useful and which is a threat, which is uncontrollable. Okay, this is what we call space debris. And if you see and this threat of space debris is becoming more and more each day, each passing day, because more and more satellites in the lower orbits are getting launched. So now the biggest problem with the space debris, even though the population of this satellite is more in the lower orbit, the lower orbits are not very stable orbits. As you may be aware, no? The lower orbit, whatever we call up to say hardly around 600 to 700 kilometer orbit, the satellites orbit decay fast and then it will re-enter the Earth's atmosphere. Once it re-enters the atmosphere, since most of the satellites are very small satellites, they will burn up. So you don't have a problem with that as well as the Earthlings are concerned. They will completely burn up like a conventional meteorites. The threat to this debris is for the other satellites. But even in the lower orbit, the present condition, it's not as high as in the case of some other scenario. But you might have heard about things like Starlink, OneWeb, etc., where people are now populating this lower orbit with thousands of satellites, not hundreds. 6,000, 7,000 satellites each and every companies are launching. Unfortunately, there is no global law which controls that. So they will continue to do that. Satellite may get affected. That's the real threat. But the real problem of space debris people are addressing only in the geostationary orbit. Okay, geostationary orbit, that is 36,000 kilometers circular orbit, is a very, very stable orbit. So whatever goes there will stay there for a long time. Okay, so this will have a problem to the other satellite where it can collide. So there are a lot of options that are also being tried to mitigate this. One is, deboost the satellite once this flight is over, push it to what you call a graveyard orbit. Okay, and third thing is capture it and bring it back to Earth. So these are all various options that are being tried. Now, the problem for Earth is not very significant from all these things because, as I told, satellites are not designed to re-enter, but when it re-enters, it will burn up. Another sense of threat for the orbital re-entry issue is for the upper stages of launch vehicle. So the last part of your question, which is more dangerous to us, is the upper stage of the launch vehicle. Because as you are aware, the upper stage of the launch vehicle almost touches orbital velocity. Right. So if something is launching a geostationary satellite, the upper stage of the satellite itself will acquire the orbital velocity. It will orbit the Earth, and after maybe 1 year or so, gradually it will re-enter. And since these upper stages are very, very big compared to satellites, some parts of it may actually fall on the land. It's really possible. Another issue is space stations. Maybe people of my generation, they will remember the case of Skylab. Americans had a space station, had Skylab, it became uncontrollable and it was a real risk of something falling on there because it's very big. Luckily, it did not fall on India, it fell on Australia. And similarly, the Russian space station here, they deliberately had a controlled re-entry. So deliberately, they landed it on the Pacific Ocean so that nobody saw it. So this is the global picture with respect to space debris. People are very actively considering it as a threat. A lot of studies are going on how to mitigate this, predominantly by the methods which I mentioned.
Any further addition to this? Yeah, I would like to mention one thing when it came to the impact of space debris. How many of you know Challenger disaster? Challenger disaster. അതിൽ എന്തായിരുന്നു സംഭവിച്ചത്? എക്സ്പ്ലോഡ് വൈൽ കമ്മിങ് ബാക്ക് അല്ലേ? So, yeah, I'm sorry. So, ഇതിന്റെ ഒരു proposal is, there's a tile which will be able to maintain the temperature. Extremely thermally poor conducting tile. For the temperature can be of the order of thousands of degrees, but other temperature will be very, very low. One of the hypotheses, it's not a fully confirmed thing, but the probable hypothesis is, the tile there was a hit by a debris, and there can be a small break in the tile. Tile is unless it is properly put, there will be a problem. So that was the root cause for the disaster. This is one of the hypotheses. I am not telling that is the hypothesis because nobody found a debris hitting in that. But then this is one of the reasons why it could have happened. Yeah. No, he had a question. Yeah.
Good afternoon, sir. My name is Navneet Chetty and I'm from Kozhikode. Well, I have two questions and they are entirely different. The first one is that, in this modern world, when in case of scientific community especially, it's more about teamwork, right? So, when we're doing a big project like we have in ISRO, there will be a number of people working in the field, from different fields working together. And each and every one of them will be having different opinions. So in total, we'll be having a multitude of opinions. So my doubt is that how does this process of a well-maintained coordination take place within the system? How are these different responses and different innovations and ideas are welcomed, and how are they analyzed, and how does this procedure take place?
Right. Sir, he'll be the ideal person to talk about.
Okay, please be seated. Today the space comes under the umbrella of Department of Space of the Government of India. So below that we have the Indian Space Research Organization. Okay, now when you talk of that, we have rockets, we have satellites and all the related things. So there are centers further broken down. You have the Vikram Sarabhai Space Center, you have the Liquid Propulsion System Center, and so on. Number of centers which are getting into basics. What I'm telling you is, when you come from a top-down thing, you're breaking it up and coming down, so that ultimately we come to a stage where you have different centers, and within the centers, they have very specific areas. Say for example, we have areas where materials are made, which are suitable for both satellite as well as launch vehicles. So what I'm telling you is, it gets broken down to a domain or an area of expertise. So that is, then in that domain, we have the experts. So it might be about material development, there might be chemists, it might be something about heat transfer, so heat transfer people will be there, it might be people who design a structure with that, they will have to do structural analysis for that. So, all these things get broken down to areas of specialization. And then, one important thing is how we really come finally to the top thing. Now, the biggest beauty about ISRO is we believe in collective wisdom. There is a committee which sits, you have the chemists there, you have the materials man there, you have the heat transfer analyst, all these people, they sit, they discuss, they thrash it out, they question, they challenge, they prove, and that is the way it goes on. So what I'm trying to drive home is, basically, it goes down to specialization, different specialization, sitting together, collective wisdom, teamwork. Okay, and then this gets reviewed stage by stage and goes. Another thing about the review mechanisms is, not anything and everything is just taken. You don't have anything readily available. If you have American technology, not available to us. You have Chinese technology, not available to us. So we might have to start from scratch. So this so-called expert in that area makes a small design. He realizes this, he does an experiment, it fails. Then he will correct it, he will redo it. Okay, so that is what I'm telling you, the process of the development of the article or the device or the component. once this is developed, it is supposed to go in the rocket. So it has vibrations, it has acceleration, it has to face heat run. So this particular article on ground is subjected to all these things. So the main message is we break down things to areas of specialization, develop the proto, qualify it, make it eligible to sit in either the rocket or into the satellite, and that is how it goes. So it is a conglomeration of today probably ISRO is about 16,000 employees, very large group. So you will ask, how do we make rockets? 16,000 people thinking differently and all. Yes, we structure it and it goes by, we have various review mechanisms. These are the beauties of that. So various levels of review mechanisms, and that is how it goes. Thank you.
Thank you, sir.
Excellent answer to that. I would like to add one more thing. All these things put together, breaking down into small cases as rightly told, and the review mechanism, they are the real core of research. But there has to be also people who understands the totality of the thing. Because they will be able to have an idea about the total system. Otherwise, you cannot break down and you cannot integrate it. So that also is required. What I am trying to tell is, if you are a super specialist in a very specific area, you'll go very deep into it. But that lateral knowledge is also essential, then you will be able to integrate things together. Yeah, you are asking a second question.
The second thing is that I'm a bit curious about that. Earlier, at the beginning of the session, we had a question regarding singularity. And as an example, an interesting case was told when air molecules just hit this aircraft when flying through the air.
Correct.
So I just want to know a bit more about this. How is singularity related with such a scenario?
The last sentence was not clear.
How is singularity related with such a scenario?
Actually, that is the place where mathematically you can say that, as you rightly told, as I understood. Let me try to understand explain from his point of view. As I understood, you have the molecules coming against the aircraft. At one particular point, the molecule has to decide whether it is going above the wing or below the wing. How does it do? That's the point of singularity, I think, which you explained. You can further.
Yeah. Because I was taking as a very simple example. In physics, we call it as a stagnation point. Okay, so which is somewhat, because it is not exactly the singularity in the later example which I mentioned, the black hole, the formation of the universe. That stagnation point is analogous to what we call singularity in abstract mathematics. That's what I was trying to explain. It's not exactly that we don't have equations of the stagnation point as it is. Okay, that is a condition where the non-equations don't give a very clear answer. To that extent, I was trying to explain. With an example, you can say you can take it more like an analogy than a very specific example. It's more because before going to the abstract case of the universe beginning, I was trying to give a very simpler physical explanation.
Thanks.
Actually, very similar things exist in several of our physical processes. The thing is magnetic reconnection. Magnetic fields are there. So when two magnetic fields come together, two magnetic fields never cross each other. Should know that. They can come together. But when it comes beyond a level, there can be reconnection. Same thing is a singularity point. You want to further explain?
For example, our Earth has a magnetic field. As you know, Earth has a core and it has a magnetic field, which actually protects us from particles from the sun. You should also know that sun emits not only electromagnetic radiation energy, it also gives out a stream of energetic particles and magnetic field. Because these are charged particles, they come with magnetic field. Now, these are, when it comes in low numbers and low magnetic field values, these particles are not entering into our atmosphere, especially in the equatorial region, because you have a closed magnetic field lines. Now, if a large plasma is ejected from the sun, sometimes it happens like transient events, and when this magnetic field is so high and if it is oppositely directed, then it can actually break this magnetic field open, and then these particles, charged particles, they find equipotential points. So magnetic field is an easy path for these particles to travel, and then they come and settle, come down to the atmosphere. Basically, it comes just like this and excites molecules therein, and it's a visible example of that is aurora forms in high latitudes.
Thank you, ma'am.
Yeah. Yeah. I think Mike.
Sir, my name is Bhavya Ravindra from Alapura. My question is that according to refraction, when one light passes from one medium to another, it changes or shifts its position. So why does it matter to sunlight while falling on Earth?
It happens. A very good question. It has two dimensions. The first thing is you are talking about light. Light gets refracted when the refractive index changes. The refractive index changes in the atmosphere. Actually very small. Of the order of, you put 6 zeros and then 1, 2, 3, 4. That means in the 6th or 7th decimal place only, refractive index changes in the air. So that way we are not able to very well see. But you have seen this. Some of the time, sun sets. You just see, sun sets. Sun rises back and sets. You understood what I am saying? Sun is setting, but the same sun rises back and then again sets. The scenario occurs when you have a plasma bubble. You know, ionosphere magnetosphere system has huge plasma. Plasma means charge, electrically neutral, but then it contains a lot of charged particles. That will change the refractive index. So, because of that, there will be one kind of refraction and it will appear as though the sun has sunk. But sun did not sink at that time. It will rise back once the plasma moves out. Of course, the plasma size has to be, plasma intensity has to be very big and size has to be smaller. Then only this event will happen. So, these kind of things happen in the atmosphere. It has one more dimension. That dimension is, you talked about light. Light is an electromagnetic radiation. You have GPS systems in your thing. Like, mobile, GPS systems are there. This GPS system works on the principle of an electromagnetic radiation, electromagnetic pulse that comes from another cluster of satellites somewhere. It is not just somewhere, well-defined orbits, well-defined positions, strategically located, and then coming here. And you are trying to find your location with respect to 3 or 4 of them. Actually 4, because if I want to locate your position, how much is from that rod, how much is from there, how much is from there? 3. And one more thing is coming is time. So there are 4. 4 minimum. It has to be more, otherwise the accuracy will be less. Okay. Here again, what if I assume is the light has come straight to you. But light is not. Light means electromagnetic radiation. It is not light which they are sending. They may be sending gigahertz signals, a few hundred gigahertz or few thousand, megahertz signals. That signal, when it came to you, it refracts through the atmosphere. And you know what is the magnitude of the refraction that will produce? It will produce a delay of the order of nanoseconds. It can cause an error in your altitude or latitude, longitude by around maybe a few tens of meters. This is okay with us, no problem. But suppose an aircraft is flying. An aircraft, the pilot sees that it has reached the ground. Okay, under normal condition you don't require anything. He can see the runway, he can do that. It's not a very big deal. But under, scenarios like in Delhi fog, just has to come down automatically. The runway position has to be exact with respect to the GPS system. GPS, I will not say GPS system, the positioning system, global positioning system. Global positioning system, there are a variety of global positioning systems. GPS is American. We also have IRMSS NAVIC. Okay, so what I am trying to tell is, when that ray has refracted through the atmosphere, through the ionosphere, it has to be exactly predicted how much is the error in that. Unless you predict that, the aircraft will crush. Because just assume an aircraft is landed, assuming that it has reached the ground, but then 10 meters away, it will be falling, it can break. Even when it falls perfectly down, you still get a jerk, correct? So that is a kind of problem. So there are people who work on this. My lab works on that. She is an expert in this area, where you have the signal that is coming, correction by the ionosphere, the total electron content in the ionosphere is what it matters. So you have to exactly know how much is the total electron content in the path in which this radiation is coming, and then you can correct it. So, the basics to your question is the refraction occurs in the atmosphere. In the visible band, it is very, very small. That is why you are telling sunlight. But in certain other frequencies, like gigahertz, where we are using our navigating signals, it can be very high, that it can be of the order of few tens or even At low elevation, it can be hundreds of kilometers. You want to add further to that?
There are two effects. One is, as Sir correctly told, about this ionosphere and lower atmosphere. Sometimes this effect of ionosphere is like frequency, called dispersive, like frequency dependent. So your choice of frequencies, calculations are all based on how much refraction happens in each of these frequencies. And that's why we have programs like Gagan, Navik, etc., which provides corrections to this by observing the atmosphere. That's one of the aspects why observing the ionosphere and modeling the ionosphere becomes so important.
Is that one question related to that?
Yeah. I think we'll come back. Because there are a few more people to ask, and then we'll come back. Because time may be so short. Others may not be able to answer.
Sir, there is one more question for me that I have read somewhere about sun dogs.
I think 1 minute. Is there any other question? Because we have to give opportunity to all, and then we'll come back to you. Otherwise, time will be lost. I think, yes, she is there. And then no, just one there.
Good afternoon, sir.
Yeah.
Sir, I would like to know about the topic that ma'am and sir just discussed. So, I am an aspirant of remote sensing. So, sir, may I know about the ionospheric haphazard layers? Haphazard layers. That is the change in density. Density of the ionosphere.
I didn't get to that second.
Haphazard
Haphazard
layers. Yes.
Okay.
So when the electromagnetic radiation is traveling through the different layers of ionosphere, it will get deviated or diffracted, and this do cause error in our GPS system. So, sir, it is my small question. Like we have the global system like GPS as well as our regional newly found IRMC system as well.
Right.
So, sir, is it easy to model the ionospheric errors in a regional situation when compared to the global system?
Excellent question. Actually, I will come to this very setup.
And sir, I will add one more question with this. Sir, the augmentation system like Gagan, how do it supports the correction of this parameter?
Okay. Excellent question. First thing is, as I told, just for the answer to you, what I told is the ionosphere, which is having plasma, that is, I use the word total electron content. The total electron, because it's a plasma. When the radiation comes, it gets refracted. Now, her question is, to what extent is it modelable? It is modelable. If I know how much is the total electron content, the equations are very straight and clear. There is no singularity in that equation. It's very straight. If I know how much is the refractive index of, the number density of the electrons, I can precisely tell the refractive index is this. Now, as the refractive, there will be an altitude profile for the refractive index. It doesn't matter to me, there is one advantage, it doesn't matter to me because all of us fly at maybe around 10 to 14 kilometers. We don't go to ionospheric altitude. Otherwise, it would have been a big problem because at 100 kilometers what is the error, at 200 kilometers what is the error, or at 90 kilometers what is the error would have mattered. But to me, it doesn't matter because the total system I am flying below. So I need to find out only the total effect. That's why I use the word total electron content. If I know the total electron content, I can precisely know how much is the refractive index. If I know the refractive index, I can accurately say how much is the delay. Because refractive index, what does it do? It retards the radiation, correct? It offers more time to travel through. It gets more refractive. This is the principle. No? So, this is very straight. Now coming to the regional thing. Can we do it in a regional way? Like what we do in our Navik system. Our Navik system, you should know, actually GPS is global. There are clusters of satellites at some 22,000 kilometers and all this. There are several of them. But for Indian region means not India. It is Indian region. It extends from probably Indonesian region to African, the Arabian African region. We have a set of satellites that are kept here in geostationary orbit. And there we can have a regional, navigation system. Okay, the principle is not exactly same as that. Actually, it's a very, very innovative idea. The Navik system is a very, very innovative idea. Okay, I'm not going into the technical details of that. The question is, can we do it better here? Yes, we can do it better. And for that, that is what is required. Regional is better. The reason being, we in STL, we have a network of laboratories spread all over the country to monitor what is the atmospheric characteristics in terms of total electron content. So I know the north-south, how much is the total electron content variation. I know along the east-west, how much is the total electron content variation. I know how does it vary during the course of the day. Now I can model it. But the moment I don't have that network, I will fail. Then I will assume certain things. Let me tell you this example. The world leader in this area is Raytheon. Raytheon is a world-renowned company who models all these things. And we found that the diurnal variation is during the course of the day, because total electron content varies during the course of the day. The uncertainties were never depicted properly in Raytheon. And the model that was developed in SPL was working far better than that. Now the question is, have we understood everything? No. There is one more. Because you can have a very short-term variation, because plasma bubbles can have very short, scale. When we say short scale, it can be 1000 kilometers. 1000 kilometers is very short for us. A bubble of 1000 kilometers is very short, very small and short. Short in time, small in size. Such things we still have to improve. But on a larger scale, yes. You want to add further?
Actually, what we have understood about atmosphere is how atmosphere is produced and what is the variability. Like you can imagine, there will be a diurnal variability because the sun rises and sets as we simply say, because you have a lot of solar radiation coming sometimes and all, and then because it has magnetic fields, it will be moving across the magnetic fields and so on. So these things we know. And we know that we have seasons, so we know that seasonal variation also exists. Also we know that sun has an 11-year cycle where sun becomes more active and less active. This kind of variations we know. But suddenly, for example, a space weather event like what I was telling happens, when a huge amount of plasma comes to the earth because of a transient event in the sun. That time suddenly all these numbers which we have in our hand changes. Changes due to neutral atmospheric changes, changes due to atmospheric electrodynamics changes, changes due to the additional magnetic field and charged particle which comes. Then you are in totally havoc situation. Likewise, we have instabilities or like bubbles which we told. Those bubbles are actually related to sudden change. It's like an instability where low density fluid is below and a high density fluid is above. Then you slightly trigger it. It can actually grow into a very unstable situation. Large bubbles can grow. So, but we don't know whether this trigger will come today or tonight or tomorrow. That once that trigger is there, then only this bubble will develop and all these irregularities or instabilities will happen. So, given all these background conditions, season, solar cycle, or diurnal time, all these being identical, also ionosphere can behave so differently in some occasions. Those occasions we don't know precisely. So that's why we need to have more like modeling efforts or observations and understand all these processes and observe them and try to have empirical models and so on and so forth. So that's how it goes on. Yeah.
You want to add further to that?
Well, I think you've been asking a question. I want to ask them back a question. What is this session about?
The skill sets need for a scientist.
Yeah. And you really took us onto a different track. You took us into physics, astrophysics, and everything. Okay. So I was craving to tell you about that, So with the permission of the key person, I scribbled down something. I'm not going to explain, but I really wish that you note down these points and then think about it. Okay? The first thing required to become a young scientist is to become inquisitive and ask how and why. I hope you have noted that. The next thing, you should become really good at literature survey. You're done?
Yes.
The next thing, you have to develop analytical and investigative skills. The next thing, you need to have good communication skills, both oral and written. You should be good at visualization and model making. You should be good at experimentation. When you are doing experimentation, you should also be very familiar about safety, the related safety. You do some experiment and bang, it goes. Sir was telling about that. You need to be both quantitative and qualitative. You just can't keep saying in words, right? Yeah, it is so big and so large and very big and very heavy. No. You need to be also quantitative. You should speak in numbers. Needless to say, you need to have good computer skills. Today, everything depends on time. So we should be very effective in time management and planning. If you are slow in your research, others will win over you. So time management and planning. Next one is, you are likely to have multiple alternatives. So you should be good at making decisions, decision making. The next point is, you need to have a sense of cost or costing. How much it costs. I was telling you about applied research where you're going to make models. I make an item, a mobile for example, which costs 5,000 rupees, and with similar features, Shiju Chandran makes for 15,000. Which one will you buy? The cheaper one. So sometimes that becomes, provided they are like to like. So cost effectiveness. So I think there are many more things that one can keep adding, but to become a good young scientist, these are all some traits which we need to develop. Thank you.
It was very illuminative, sir. We'll come back to this particular point after this.
I just want to add to that, because that's just a very important point. First thing what he's told is inquisitiveness, where you ask questions. But let me ask you very frankly, how many times you have asked a question to someone and they said, don't ask this question, what's the reply? How many times? You would have asked this question to a teacher, probably. You would have asked this question to an elder. You have asked this question to a person of authority. Many times you would have got the answer. Don't ask all those things. Right? So, naturally next time, when there is a question in your mind, which is the inquisitiveness what sir is talking about, you won't ask. You just accept the answer which is recognized, right? Or the authority gives you. So, first thing about that is what we call the skepticism and critical thinking. If someone says something to you, he may be a person of authority. He may be a person in a uniform, whatever uniform he is wearing. Don't just accept that without critically thinking, analyzing it. If you have not understood it, ask a question. Right? And then get convinced. So this is the most important thing for a scientist. Without this, you cannot be a scientist at all. The moment you lose your sense of skepticism and critical thinking, you are no longer a scientist. You can be a person who makes money out of science. You can be a person who works in a scientific institution, but you are never a scientist. Right? So critical thinking is very important, and that depends on society. There are so many societies which discourage questions. The moment you ask a question, you say, no, these are all the things which are accepted, don't ask questions. So that is why, when you are 15 or 16, if you want to be a scientist, you have to unlearn a lot of nonsense which has gone into your mind or pushed down in your mind, which you have accepted without critical thinking. This is very, very important. Unless you do that, you will know all the theories of science, you know all the principles of science, but you can never be a scientist. There is a huge difference between a scientist and a person who makes a living out of science. Be understood, be very, very clear about this. So, inquisitiveness, everything goes hand in hand with what I just mentioned. So, this is extremely important. Okay.
Yeah, I will come back to this because we have to share vast experience, sir, and this. So, your question, you can complete it and then we will come back.
Sir, myself Anne-Maria. I'm coming from Kozhikode. I have done my SSLC examination last month. ആക്ച്വലി ഞാനിവിടെ ചോദിക്കാൻ വെച്ചിരുന്ന ക്വസ്റ്റ്യന്റെ എല്ലാ ഉത്തരങ്ങളും നിങ്ങളിപ്പോ ഇവിടെ ചർച്ച ചെയ്ത കാര്യങ്ങളിൽ നിന്ന് കിട്ടിക്കഴിഞ്ഞു. എന്റെ ക്വസ്റ്റ്യൻ ഇതായിരുന്നു, ഒരു യുവശാസ്ത്രജ്ഞൻ, എനിക്ക് മേഖലയെ പറ്റിയാണ് ക്വസ്റ്റ്യൻ ചോദിക്കാനുണ്ടായിരുന്നത്. ഒരു യുവശാസ്ത്രജ്ഞന് ഒരു എഡ്യൂക്കേഷൻ ആയിട്ടുള്ള ഒരു ക്വാളിഫിക്കേഷന് പുറമെ അയാൾക്ക് ഒരു റിയൽ സയന്റിസ്റ്റ് ആവണമെങ്കിൽ അയാൾ എല്ലാവരുടെ കീപ്പ് ചെയ്യേണ്ട ഒരു ക്വാളിഫിക്കേഷൻ എന്തായിരിക്കണം? ഈസ് ദാറ്റ് ഹാർഡ് വർക്ക് ഓർ പേഷ്യൻസ് ലൈക്ക് ദാറ്റ്? നിങ്ങൾ ഇത്രയും കാലം ഒരു ഫീൽഡിൽ വർക്ക് ചെയ്തതിന്റെ ഒരു എക്സ്പീരിയൻസിന് പുറമെ, ഇൻ യുവർ ഒപ്പീനിയൻ, വാട്ട് ഇസ് ദാറ്റ്? സോ
actually the answer was already told and the answer is there in your question itself. First and foremost is you should be ready to question. Inquisitiveness. Should be ready to question. Don't accept the precedent. Don't accept your beliefs as it is. Unless it is. See, we have our gurus. BVK is our guru, several of us. Even at the age of 80, you may ask him something which he may not know. So long as you don't know, I don't know. So long as I don't understand, I don't understand. You all may be understanding, you all may be correct. But I am not convinced. You understand? This is called critical thinking. You have to think yourself, you have to get it in your brain. However hardworking you are, it cannot be replaced by this kind of a thinking. At the same time, a person can think like anything but then amazing, but then if he is not focused, if he is not having, the dedication, the hard work, it will not be sufficient. And third is unconditional. Very many times in research, you may end up in the wall. You will not get result. But if you start thinking that, no, that will not yield, I will fail. No. You have to keep on going for that and finally you will win. So it should not be for getting something, like getting an award or getting a position. No. You should have things without all those kind of things to understand basically what is the process. Your question, things should be only that. All other things will follow. You will be able to solve your question, but then focus is required. What you are targeting, you should know. You should not stray into finding out something. You should be well focused about what exactly you want to do. But otherwise, sir has already explained, and Shiju also has explained. You want to add anything further? Sir, would you like to comment on this, sir? Okay, so we'll come back. Actually, Suresh is one person who really will be best for answering these things. But we'll come back at the end anyway.
thanks.
Yeah. Any other questions? Yeah. Before that, I would like to ask the organizers, how much time do we have? Any idea?
We were expected to finish it by 1:15 for lunch.
But maybe we'll take another 10-15 minutes? Or 10 minutes at least?
Yeah, sure.
Yeah.
Sir, my name is S. Krishnan. I'm studying in 5th grade at JHS Kathani, Thiruvananthapuram. My question is, what is dark energy or dark matter?
Excellent. See, you can theoretically calculate how much is the total mass of the universe in principle. In principle, this is theoretical calculation. But as per the current thing, the energy that is available in the universe or the total mass of the universe, theoretically, when you practically observe, is largely missing. The substantial difference between the actual energy or actual matter in the sense mass, that is observed, and what is theoretically possible. The difference comes because of the aspects like dark. One is, dark means you are not able to find physically, but they exist. In what form they exist? They can exist in a variety of forms. Neutrinos it can be, because neutrinos itself, the hypothetical conditions for the amount of neutrinos that should be available is not the amount that we already found out. Black holes, antimatter. So there are several things which we did not detect so far, but they exist. Both these things fall in that category, both in terms of the dark energy and dark matter. There are missing energies and missing matter, which is there theoretically, but which is not practically observed, but they exist. And there are theoretical hypotheses in which form they exist. That also is there. It doesn't mean that we understood, okay, only in this form the missing mass will exist. No, there can be some other form also. One example is black hole. Because black hole is only inferred. Black hole is not actually observed. It is inferred. I can observe you. I can infer the position of you. These two things are different. Black hole is inferred. Presence of black hole is inferred. Because there are several conditions, when rays get refracted out, so many things are there. Or there are various ways in which you can get the movement of a planet around that, or movement of a star around that. All those kind of things are indicative but not direct. Yeah.
Sir, with your permission, it's already 1:15 now, so we'll have 2 more questions with the panelists.
Yeah.
So, and students? Okay, 2 more questions.
Sir, my name is Abdev.
You can remove your mask. Not very clear. Yeah.
My name is Abdev. I'm from Kozhikode, and my question is, how could a space agency protect its astronauts from radiation while on a trip to the moon?
How an astronaut is protected? Is that the
From
question?
radiation, yes.
Through radiation. Yeah. I think we have a person who was actually designing the spacesuit itself.
Actually, radiation, it's not Goddard Space. You asked something like Goddard Space Center? Yeah, it's not specifically Goddard Space Center. No, first question, how Goddard Space Center do that? Okay, I heard that. Yeah. Actually, the radiation is a major issue. In fact, when people are proposing this given space flight, one of the strongest challenges for that come from the physics community, who said if you are exposed to radiation in deep space, you will be having problems. And in fact, there has been problem reports of it. I give a very basic answer. It's simply by providing a particular chemical which absorbs most of this radiation. That's the reason how you protect the astronauts. So there are certain commercial, like if I remember currently the names are Nextel or something, I don't exactly remember, but these are basically hydrogenous polymers which will be covering the spacecraft and they will absorb the radiation. Okay. Now the issue becomes very, very critical when the astronaut goes outside the spacecraft. For example, when they are landing on the moon or when they are doing the spacewalk, they are going outside the spacecraft. So what they have to do, they have to protect themselves from the outside radiation by using a flight suit. So conventionally, how do you protect from radiation? You use a lead blocks and other kind of things. You are familiar, no? But in space you cannot do that. So what they have done, they have done 2-3 methods. First is, they will always select an orbit which is very, very favorable as far as radiation is concerned. They will deliberately avoid what we call the so-called radiation belts, where this kind of severe issues are arising. So they will avoid this orbital selection. In fact, going to moon there was a concern in it because they may have to cross what we call the Van Allen radiation belts, etc. So when they land on the moon, the flight suit, whatever they are using, they are having layers of radiation absorbing material. Now, again the question is how long it can be done. So there are conditions, there are in fact the units of radiation which is basically called the sieverts, millisievert, Browns, etc. So there are studies done here on Earth. How long a human body, how long our biological tissues can be exposed to the radiation. So they have calculated, there is something like years and years you have to be exposed before having some kind of it. I'm just giving a number. So they always ensure that the astronauts trace out, even with the protection, to a duration which is lesser than this. So 2 things are there. There is something called a mitigation strategy, as well as there is a direct, avoidance strategy. So first they will avoid all these critical zones where it can happen. Second thing is, whenever they go, they provide a radiation protection system. So this is how they are protected. Is it clear?
Yeah. One more question. Yeah. I think this is the last question. You have a second question, but I think they limited to 2. After this, you can interact with us, no problem. We have time.
So my name is Krishnendu and I am studying in 10th standard at GHS Kozhikode. And my question is, if a person in a terrorist organization is making all the scientific equipments in the organization, can we call him a scientist? Because science is mean for the good of the society, right? So can we call him a scientist?
So can you...
I would just say like this, he's still a scientist. Why you say that he cannot be called a scientist? Actually, the word scientist, the word nature, they are all neutral. We always say that forces of nature. Forces of nature is neutral. The forces of nature will kill hundreds of babies with the same nonchalance as it may help. humans with all this, what we call the rain and all this kind of thing. It is neutral. Scientist is a neutral term. If you work for Hitler, like the great Fritz Haber, have you heard about Fritz Haber? Fritz Haber might have saved millions and millions out of starvation by finding a process of making ammonia. And ammonia is the fundamental chemical for the fertilizers. The same Haber has created all these, the dangerous gases which the Hitler has used to kill people. So he is still a scientist. He makes use of science. He is still a scientist. You have heard about persons like Robert J. Oppenheimer. Is it not? Robert J. Oppenheimer made the nuclear bomb. First great scientist, one of the most well-known scientists. Edward Teller made the hydrogen bomb. Khrushchev, the Russian, they all made weapons of mass destruction, what we call. They are still scientists. So you can, next question is, there is a good scientist or bad scientist depending on the way you see yourself. Okay, these are all neutral terms. Don't please think that a scientist is only one person who works for the good of humanity. Then you can call him a good scientist. That's
I would request sir to, give the advice on, he is one person, as sir told, picked up by Kalam, and then right from the scratch, he was making the things. I'd like to give your advice to the kids in terms of, building from the scratches and understanding the basic processes rather than, the way we do assembly.
I would say, in the early stages of ISRO, we never knew anything about rocket. So then I'm talking about the time when Dr. Abdul Kalam was here in the Bicatorial Organization. There, Sir Thomas told about specialization, materials and other things. We never had any grasp of it. But he also said about the literature survey. Some of the literatures are available, some of them are not available, they are considered as secret documents. So, one point is, when nothing is available, you have to find your own ways of developing it. So, started from the scratch, made something, imagined something, realized a product, tested and found whether it is meeting requirements or not. Did not modify it. So, as he has talked about what all are the things required, that was the one which has been followed in the early stages where nothing is available to us. At least today, you know many things. I found, I was really talking to him. I was surprised to see the students of this class talking so much about astrophysics, space and what all. I could never imagine that I will know even 1% of what you talk at my period of your age. So, we find that the understanding, whatever is already got, that has been very well, it has reached you and you have pursued to understand things and you have come out. So, that is something very great we found. But in earlier days, we never had opportunities. In fact, a space club like this, is something which we could never imagine. So we find that you got opportunities, you made best utilization of it, and you have come out very well. And definitely I can say that you are our promise to the nation.
Thank you, sir. Actually, that's a valuable advice. I would request you to Girish for one of the most brilliant scientists in the country. I would like to give your advice to the kids in terms of the scientific pursuit. Short.
So basically, it's not advice, my experience. It's actually our attitude makes a difference. Many other things were discussed. Because I'm in the field of research. So many times what we used to see the sparks. Some people will be suddenly interested and started doing something and then they stopped. So the attitude is one important thing. I don't know how many of you are really interested to take research, scientific research as a career. I don't know how many of you are there. Yeah, all of you, most of you. There are some, but yeah, it will also, but most of you. It's a good trend, but how long you will keep that interest? Once you take up this also, the scientific research as a career, or as Sir has mentioned, there is a difference between as a scientist and science as a for science for food. One of the version that also is there, but still it is you have to be in that, because we never, many times we don't get success. We have to probably some of our people are got success at the end of their career. One of the most successful Indian scientists, Thiruvananthapuram Chandrasekhar, he got Nobel Prize in 1983 for the discovery for the science which he has done in 1930s. 50 years, but he never gave up. He continued, and see that he is one of the best examples for to be a scientist. In 1983, he is quite old, and his brother was in VSSC. I think worked with our SARS. So he is very close to our scientific community in India, Thiruvananthapuram Chandrasekhar. So if you go through his biography, you understand how a scientist. He never complained. The scientists cannot complain. We have to have solutions to the problems. We are not problem creators. We look for problems and we have to have solutions to the problems. What I understand from my experience is actually the most important quality a scientist should have is to generate scientific question. If you give question to someone, if you get a question, I feel it is easy to find the answer to a non-question. But if our exam pattern is changing, you are given a lot of books and ask you after studying all these things, create a question which no one has asked so far. And those who do that, they will be qualifying the exam. Now it's quite easy. They are giving the question, we are giving the answers, isn't it? So they are giving a scientific book, and then they are asked us to create a question, and it's very difficult. So the most important quality, sir has mentioned, that asking questions. So creating question is the most important thing. That is the area which we are struggling. That we have to create questions. Once question is created, answer will automatically come. It is when we try to get the answer. So that is the one single point which I would like to highlight here. Thank you.
Before that, I would like to introduce Smita, as he has rightly told. She is one of the most brilliant scientists in the country. Forget about the gender, because actually it is not the case because of gender, but because of the capability. She is made discovery class results, findings from Chandrayaan 1, Chandrayaan 2, America. That is a must.
Thank you, sir.
Thank you, sir.
Thank you, sir. I'll just summarize in 2 words: passion and hard work. These two will drive you towards more and more discoveries, more and more science. Your passion should drive you, not the awards or honors or your career or whatever. It's your passion towards truth, finding the truth, and then your hard work. This will drive you further.
I think the time is not there, but still, sir, one minute you want to tell something? So I thank each one of you for providing the excellent answers, and some of the questions which we did not answer. One is, we don't want to give you Google answers. Answers should be authentic. The second thing is, it also means that we have so many things which are not known compared to what we know very little. So thank you very much for your time listening, and thank you, sir, for sharing your experiences. Thank you. And thank you for giving us an opportunity to interact with you, because interacting with the children is the most dangerous thing in life. Okay, thank you.
Thank you, sir. Thank you so much. With this, we have come to the conclusion of our panel discussion. UN Space Club is extremely grateful to all 6 panelists, Dr. K. Rajiv, Sri C.P. Karta, Sri Thomas C.R., Dr. S. Suresh Babu, Sri Shiju Chandran, and Dr. Smita Tamari. A round of applause is an obligation.
Thank you, sir. Thank you for inviting with us, and we are a honor for you. For that, I would like to invite Dr. Vaidyan Krishnamurthy sir to stage for honoring our panelists. We would like to welcome Dr. Suresh sir. next we would like to welcome Dr. K. Rajiv, Director of SPM. Next, we would like to welcome Dr. Smidagi Tarnima. Thank you, Arvind sir. Arvind sir, thank you for him. Next, we would like to welcome Dr. V. Adimoti for honoring other panelists. Dr. Sia Thomas, please. Dr. C.D. Kata. Yes, sir. We would like to welcome Dr. Shiju Chandra. Thank you, Adimati sir. Thank you for joining with us. So we would like to express our gratitude to all panelists for interacting with us and answering all our questions. Thank you, sir. Thank you so much. And we have an announcement for you from Bharat. Bharat.
Okay, so with this, we may disperse for the lunch. And all students are requested to please stick to time and be back and seated before 2 p.m. May I please repeat? All students are requested to please be back and seated by 2 p.m. Also, students who are to present their projects are to be back as early as possible. And we also request you to make sure that you stick to the time allotted. So we may all disperse for lunch. Thank you.
പ്രസന്റേഷനുള്ള കുട്ടികൾ എത്രയും പെട്ടെന്ന് ഫുഡ് കഴിച്ചിട്ട് മടങ്ങി വരാം. 4 കുട്ടികളുടെ പ്രസന്റേഷന് പേരെന്നാറുണ്ട്. അവര് ഏറ്റവും ആദ്യം ഫുഡ് കഴിച്ച് മടങ്ങി വരാം.
കുറച്ചുകൂടെ അടുത്ത് ആടോ ആ
എല്ലാവരും എത്രയും പെട്ടെന്ന് ഭക്ഷണം കഴിച്ച് തിരികെ വരും.